Welcome to the DIY Honda Garage channel. This presentation discusses Diagnostic Trouble Code, DTC P0335, which indicates that the crankshaft position, CKP sensor, is not sending a signal. This issue can significantly affect engine performance since the CKP sensor plays a crucial role in monitoring the crankshaft's position and speed. Its accurate signal is essential for the engine control unit, ECU, to manage ignition timing and fuel injection. The CKP sensor is typically located near the crankshaft in the engine block, making it accessible but sensitive to damage from external elements. Recognizing this DTC is vital as it indicates potential issues that may lead to poor engine performance or even failure to start. This troubleshooting guide will systematically address the potential causes, symptoms, and the necessary diagnostic steps to identify and resolve the underlying issues leading to this error. DTC P0335 indicates a failure of the crankshaft position, CKP sensor, to transmit a signal. The CKP sensor is essential for monitoring the crankshaft's rotational position and speed, allowing the engine control module, ECM, to optimize ignition timing and fuel delivery. If the CKP sensor malfunctions, it can lead to significant engine performance issues, such as stalling or failing to start, as the engine relies on accurate crankshaft position data for operation. This sensor is typically located at the rear of the engine, aligned with the crankshaft, making it crucial for effective monitoring. It gathers critical data that helps maintain engine efficiency and performance during operation. Understanding the role of this component is key to diagnosing and repairing issues related to this DTC. When facing DTC P0335, there are several possible causes to consider. One common issue may be poor connections or loose terminals at both the CKP sensor and the powertrain control module, PCM. Loose or corroded connections can interrupt the flow of data necessary for proper engine function. Another potential cause involves an open circuit in the wiring between the CKP sensor, relays, or the PCM. Any breaks in the circuit can lead to this signal error. Additionally, a faulty CKP sensor itself may be the root of the problem, either due to wear or damage. Lastly, issues with the PCM, the central unit responsible for processing sensor data and managing engine functions, could also cause DTC P0335. Identifying the exact cause is vital for effective repairs. When encountering DTC P0335, several symptoms may manifest, indicating a potential issue with the CKP sensor. One of the primary signs is engine stalling, which happens as the ECM fails to receive necessary information to maintain engine operation. Drivers may also experience difficulty starting the vehicle, as the engine control module relies on accurate crankshaft position data for proper ignition timing. Additionally, poor acceleration can occur as the engine's performance relies on optimal fuel delivery and ignition timing, both influenced by the CKP sensor. Lastly, the check engine light will likely illuminate on the dashboard, serves as an alert that the vehicle's onboard diagnostics have detected an issue that requires attention. Recognizing these symptoms promptly can help prevent further complications. The first step in troubleshooting DTC P0335 involves verifying the problem by using the Honda Diagnostic System HDS. Begin by turning the vehicle to the on mode, but do not start the engine yet. Next, clear any stored diagnostic trouble codes using the HDS. This process resets the system and allows for a fresh evaluation. After clearing the codes, start the engine and check for any pending or confirmed DTCs once again via the HDS. If DTC P0335 appears again, it confirms a continuing failure. thus leading you to proceed to the next troubleshooting step. If it does not appear, the issue may be intermittent, warranting further investigation of connections to the CKP sensor and PCM. The second troubleshooting step focuses on checking for open circuits in the wiring. To initiate this step, ensure the vehicle is turned off and in the lock mode. Next, disconnect the CKP sensor's 3P connector to isolate it from the circuit. Following this, turn the vehicle to the on mode without starting the engine. The next part involves measuring the voltage between specific test points. Test point 1, which is the CKP sensor connector's female terminal number 3, and test point 2, which is the vehicle's body ground. The goal is to ascertain if there is battery voltage present at the CKP sensor connector. If battery voltage is present, this indicates that the power supply and wiring from the relay circuit board are functioning correctly, allowing you to advance to Step 3. In Step 3, you further investigate the potential failure areas concerning the wiring. Start again by measuring the voltage between two specific test points, while ensuring the CKP sensor 3P connector remains disconnected. Here, test point 1 is the CKP sensor connector's female terminal number 1, and test point 2 is still the body ground. The aim is to determine if there is approximately 5.0 volts present. If this voltage is observed, it suggests that the initial wiring is intact, allowing you to proceed to Step 4. Conversely, if the voltage is not present, this indicates a fault in the circuit, urging you to go to Step 5 for further examination. Step 4 involves conducting an open wire check on the LG-LG2 line, which is crucial in determining the integrity of wiring associated with the CKP sensor. Begin by measuring the voltage between two specific points, again with the CKP sensor 3P connector disconnected. Test point 1 will be female terminal number 2 of the CKP sensor connector, while test point 2 will reference female terminal number 3 on the same connector. This step aims to verify if battery voltage is present at the designated test points. If battery voltage is confirmed, this indicates that the LG-LG2 wiring is intact and suggests the CKP sensor may be defective, prompting its replacement. If no battery voltage is observed, this points to an open circuit in the LG-LG2 wire, requiring repairs to restore connectivity. In the fifth step, the focus shifts to checking for any shorted wiring in the CRKN line. First, turn the vehicle to the off, lock mode to safely conduct testing. The next action involves jumping the SCS line using the Honda Diagnostic System, HDS, and allowing it to sit for more than 1 minute to prepare for continuity testing. Once prepared, disconnect the PCM connector B, which is labeled as 51P, to isolate it from the circuit. To check for continuity, examine the connection between two test points. Test point 1 is female terminal number 38 of the PCM connector B, and test point 2 is the body ground. If continuity exists, this signifies a short in the CRKN wire between the PCM and the CKP sensor. This problem requires immediate repair to restore circuit integrity. If continuity is absent, it indicates that the CRKN wire is not shorted, allowing you to advance to Step 6. In the final troubleshooting step, you will perform an open wire check on the CRKN line. Begin by connecting terminals A and B using a jumper wire. Terminal A will be the CKP sensor 3P connector's female terminal number 1, while terminal B will be the vehicle's body ground. After the connection is made, check for continuity between two designated test points. Once again, test point 1 is female terminal number 38 of the PCM connector B, and test point 2 is the body ground. If continuity is confirmed, it indicates that the CRKN wire is functional. and further investigation is warranted either through authorized service information or by substituting a known good PCM. If, however, continuity is not present, it suggests that an open exists in the CRKN wire between the PCM and the CKP sensor, necessitating repairs to restore proper functionality. After completing the necessary repairs, it is essential to verify the effectiveness of the repairs on DTC P0335. Begin this process by clearing all DTCs using the Honda Diagnostic System, HDS. Once codes are cleared, conduct a test drive to allow the vehicle to operate under normal conditions. During this drive, monitor performance indicators to ensure that the previous symptoms no longer present themselves, such as stalling or difficulty starting. If the vehicle performs without issues, this further verifies that the CKP sensor and associated wiring faults have been appropriately addressed. It is advisable to perform multiple runs to confirm the repair's success, because intermittent issues can sometimes resurface after initial testing. Final checks should include reassessing the check engine light status, ensuring that no new codes appear. To prevent future issues with the CKP sensor and minimize the risk of encountering DTC P0335 again, engaging in preventive maintenance is essential. Regular inspections of the CKP sensor and its connectors are crucial, ensuring that all connections remain secure and free of corrosion or debris. Cleaning connectors periodically can help maintain effective conductivity and prevent signal disruptions caused by dirt and moisture buildup. Additionally, replacing any worn or old CKP sensors before they fail can save time and prevent unexpected breakdowns. It's wise to follow the manufacturer's recommendations for service intervals, paying particular attention to other related components in the ignition and fuel systems. By implementing these preventive measures, vehicle owners can help ensure smooth engine operation and reduce the likelihood of DTC occurrences. In conclusion, DTC P0335 indicating CKP sensor no signal is a critical error that highlights the importance of the crankshaft position sensor in engine performance. When troubleshooting this DTC, it is imperative to follow a systematic approach to diagnose potential wiring issues, sensor failures, or even PCM problems. Recognizing symptoms early allows for effective repairs and mitigating further complications. Additionally, adopting a preventive maintenance strategy will assist vehicle owners in maintaining optimal performance while reducing the chances of similar error codes appearing in the future. A thorough understanding of how each component functions within the system is essential for both diagnosis and repair efficiency. Adhering to these guidelines will promote longevity and reliability in Honda CRV vehicles from 2017 to 2022. Please like and subscribe to the channel. See you next time.